Hi guys, in the last video we were discussing about maximum gap using erratic sort. Now we will be implementing erratic sort. So to implement erratic sort, basically I will write a function. The function, let's say limit to void, as we don't need to return anything, then void erratic sort in size of the array. Then here, what was the first step? Step 1, get highest MSB count, and then step 2, sort each significant bit by using count sort. So first get highest MSB count and highest MSB place is equals to fetch highest most significant bit place in array of size n. This will return an int value. Takes integer array and integer size in value. Then we will go with int maximum MSB is equals to 0 for int I is equals to 0, I less than n I plus plus. Let's just get the maximum element first. Max element, which is max element is equals to math dot max of max element comma AR of I, and then return string dot value of max element dot length. Okay, yes, that is 3. Now we have to sort for each significant int significant is initializing as 1, then for int I is equals to 1, I less than or equal to 3, not 3. 3 was in the example is then or equal to highest MSB place, then a plus plus count sort here array length of the array please. You have to put this operation as well. This is not a condition, that's why it should be here. After each iteration, multiply this with significant place with 10. Now we get the highest MSB place. Now we have to do count sort. So void count sort int arr comma int n comma int place. Okay, let's name this as we will say exponential or place only. Okay. Now after this, what we can do, we have to deploy the count sort. So to do that, we need a array of count of size 10, and so each significant bit, that is each of these places, each digit can be from 0 to 9. Okay, so each digit can be 0 to 9, so that's why we are using count with we are keeping count of each digit in that particular place. For computing that, we need a count array of size 10, and let's say there is an output array which will show the sorted array of same size or as the array. Okay, now let's traverse the array I less than in I plus plus. Okay, now here I will compute first I will compute the number of count of occurrences of each digit at particular digit place in the array, which we will compute using division and modulo. It would be the place would be divided by place multiple modulus 10. This would eliminate all the digits all the LSB digits after the current place, and this should get the last digit only. Once I get the plus plus, now get cumulative counts for each digits. What I mean by this is, for example, let's do a count sort over units digit. Okay, so count sort, let's go on the next page. So count sort on unit place. So here initially the in the first phase I would have 9 digits, that would be 0 0 0 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 0 9. Okay, 10 size array. First I will initialize count as 0 0. Then for unit place I will update this as I will update this, so it would be first 0 is coming once, then again 0. So the indexes for these are like 0 1 2 3 4 5 6 7 8 9. These are the indexes associated for each of the zeros. I'm writing this so that it will be easier to associate at which index it is there. Don't mind my drawing, it's pretty bad. Okay, now first element has 0, so this will become 1. Then 5, this one will become 1. Then again 5, this will become 2. Then again 0, this will become 2. Then 2, this will become 2. Now 4 will become 1. Then again 2 was 1, right? Yeah. this place it will become 2 and 6 come 1. Okay, so yeah, so we are computing this using this simple formula. Now after this we will do a cumulative sum. So cumulative sum, 2 here 2, we will start from one index which is 0 plus previous index which is 2, then 2 plus previous index, this is 4, then 0 plus previous index again 4, then 1 plus previous index 5, then 5 2 plus previous index value 7, then 1 plus previous index value 8. Similarly all these are 0, these should be also compute similarly. 0 plus previous index value 8 is 8, this should be again 8, this should be again 8. This will be doing, so it is like 4 int I is equals to 1, I less than n I plus plus count I plus equal to count I minus 1. Why we are doing this? We are doing this because this is actually a step we are doing this in which is used to find out the place where we will be keeping the elements in a sorted manner. You will understand the meaning of doing this in a moment. So using cumulative counts for each digit, we will make the output sorted array. This I will start from the end. In 1 I greater than or equal to 0, I minus 1 is, and then we will assign output array like count AIR of I. First I will check that the digit place value is considered at what place in that cumulative sum. So now you will understand why cumulative sum was required. Cumulative sum is required because to know whichever element is present with the digit, let's say 9, 8, 7, 6, 5, where it will be placed. So for example, element with cumulative sum of 8 would cumulative sum of 6 would be placed at what place? it would be 0 1 2 3 4 5 6. This will be the place, 8th place, and we will decrement this also, because it might happen that there are multiple elements with 6. For that I will take one example, that is, let's say 4. Okay, so where I would place elements that are having unit place as 2, we will place either at 4. If 4 is done, it will decrement to 3, and then we will place it at third place. So it will be like output calculated place position, that is I divided by place modulus 10. This is the same formula like this one, you can see it. And so this would be 10. Is equals to of I. Now why I am doing -1? Can you guess? Can anyone guess? Okay, I will tell you. So this is because of 0th order indexing. Here the values are currently are here. From this I am deriving the position considering 1 order indexing. 1 order indexing means elements are stored in first. Elements stored in the array is starting from first place, not the 0th place. To start with 0th place, I am just decrementing it with -1. After this, what next step you have to do? Very good, I have to decrement this count value to get the next position for the next occurrence of this digit. Now I got the sorted element in the output array. Now I have to reassign the ARR integer with the output array. I can either do this, or I can directly assign as well, or directly make a clone out of it also. Anything works. Okay, minor compilation error, cannot find symbol, edit sort, did I name something else? Edit sort, what were the other mass element? Max element. Okay, what else? These are the comparison. Let's see, it works out in the public discuss. Let's submit this. This is showing 58 ms, but sometimes basically Leetcode use random test cases, so that's why it is showing here. Maybe So the for this the time complexity is of n. You can also check of n. Okay, thanks for watching. Please subscribe, share for getting this to a wider audience. For now, bye bye.